Myself, Rajendra Eskarale. My qualification is MSc Chemistry B.Ed and experience is of 28 years. Now today we are going to discuss about failure of valence bond theory and need for the concept of hybridisation. Now the valence bond theory valence bond theory failed or need for the concept of hybridization to explain following facts are. Now failure of valence bond theory meaning is that the need for the concept of hybridization. Now here first to explain observed valences of certain elements. Example, beryllium, boron and carbon, etc. Now here first write down the electronic configuration of beryllium, boron and carbon in the ground state. That means here EC of beryllium, boron and carbon in the ground state are B 1s2 2s2 and here write down 2p0 boron 1s2 2s2 2p1. That means here according to the Hund's rule, that is 2px1 2py1 y0 and 2pz0. In a similar manner, write down the electronic configuration of carbon 1s2 2s2 2p2. Again apply your Hund's rule. That means 2px1 2py1 and 2pz0. Now from this electronic configuration it is clear that beryllium, boron and carbon contain 0, 1 and 2 unpaired electrons. In the valence shell. Now listen here. Here beryllium have no unpaired electron, meaning is that 0 unpaired electron. Boron have 1 unpaired electron and carbon have 2 unpaired electron. Here you can use the word that is respectively. That means here beryllium, boron and carbon contain 0, 1 and 2 unpaired electron in the valence shell respectively. That means here beryllium, boron and carbon should be 0 valent, monovalent and divalent respectively. But here but beryllium, boron and carbon are divalent, trivalent and tetravalent respectively. This is because now we are write down element and your stable compounds. Beryllium form the stable compounds like BeF2 and BeCl2. Boron form stable compounds like BF3, BF3 and BCl3, and carbon form the stable compounds like CH4, CCl4 and CS3Cl. That means now why beryllium is divalent instead of zero valent, why boron is trivalent instead of monovalent, and why carbon is tetravalent instead of divalent. This can be explained on the basis of promotion concept. Which is also called as excited state. Now, what is the definition of excited state? Promotion of electron from lower energy level to higher energy level due to absorption of energy. Now listen here. The excited state is nothing but the promotion of electrons from lower energy level into the higher energy level due to the absorption of energy. But most important question is that from which source this energy comes here. Now, formation of covalent bond is accompanied by the liberation of energy or evolution of energy. Now, the amount of energy is released here is used to promote electrons from lower energy level to higher energy level. Now here in this case you will get the new concept, that is excited state, and keep in mind the definition of this excited state, that is promotion of electron from lower energy level into the higher energy level due to absorption of energy. But from which source this energy comes here? Formation of covalent bond is accompanied by the liberation or evolution of energy or release of energy. This energy released during the formation of covalent bond is used to promote the electrons from lower energy level into the higher energy level. Now here electronic electronic configuration of beryllium, boron and carbon in the excited state are, that is a beryllium 4 1s2 2s1 2p1, that is a 2px1 2py0 and 2pz0. Boron 1s2 2s 1 and here 2p2, that is 2px1 2py1 and 2pz0. And here write down carbon 1s2 2s1 2p3, that is 2px1 2py1 and 2pz0. That means here beryllium boron and carbon contain 2, 3 and 4 electrons in the valence shell respectively. Now let us observe here electronic configuration of beryllium, boron and carbon in the excited state. Beryllium atom have 2 unpaired electron, boron atom have 3 unpaired electron and carbon atom have 4 unpaired electron in the valence shell. Hence beryllium is divalent, boron is trivalent and carbon is tetravalent. Now keep in mind the most important concept here is that according to the valence bond theory, beryllium is zero valent, boron is monovalent and carbon is divalent, but actually beryllium is divalent, boron is trivalent and carbon is tetravalent. That can be explained on the basis of promotion concept, which is also called as excited state, and this is the origin of hybridization. Now then write down second, to explain observed geometry Now here write down example. Formation of methane that means here CH4 molecule. The molecular formula of methane is CH4. It contains 1 carbon and 4 hydrogen atom. Here EC of carbon in the ground state, that is 1s2, 2s2, 2p2, that is 2px1, 2py1 and 2pz0. Now here 2p atomic orbital of carbon atom overlap with one s atomic orbital of two hydrogen atoms. These two 2p atomic orbital are mutually perpendicular to each other. That means by making an angle of 90 degree, and hence SCH bond angle is of 90 degree. That means this one and this one here H, here also H. Now one 2s atomic orbital of carbon atom overlap with 1s atomic orbital of hydrogen atom. Actually, s atomic orbital is spherically symmetrical. Hence, overlapping is possible in any direction, and hence third SCH bond is also of 90 degree. Now the fourth SCH bond will be of any angle, but actually all the four bond angle in methane are 109 degree 28 minutes or 109.5 degree. Now this is the second limitation of valence bond theory. Third, or need for the concept of hybridization. Third, to explain equivalent nature of all bonds and codes, to explain bond angle in the given molecule. Now we are write down one question. According to VBT, that means valence bond theory, beryllium, boron and carbon are number A divalent, trivalent, and tetravalent. Number B zero valent, monovalent and divalent. Number C divalent, tetravalent and trivalent. And here D monovalent, zero valent and divalent. In order to write down the answer of this question, first write down the electronic configuration of beryllium, boron and carbon in the ground state. After writing the electronic configuration, you can find out the number of unpaired electrons in the valence state. Now, beryllium have no unpaired electron in the valence shell, therefore it is 0 valent. Boron have 1 unpaired electron, so it is monovalent, and carbon have 2 unpaired electron, so it is divalent. Here correct answer is 0 valent, monovalent and divalent. Second question, according to promotion concept, or excited state, beryllium, boron and carbon are, again here write down same option, divalent, trivalent and tetravalent. Here number B, 0 valent, monovalent and divalent. Number C, divalent, tetravalent and trivalent. And number D, monovalent, 0 valent and divalent. Now here, in order to solve this question, write down the electronic configuration of beryllium, boron and carbon in the excited state. And let us observe that electronic configuration. Beryllium have 2 unpaired electrons in the valence shell, so beryllium is divalent. Boron have 3 unpaired electrons in the valence shell, boron is trivalent. And carbon have 4 unpaired electrons in the valence shell, therefore carbon is tetravalent. And this is your correct answer here, divalent, trivalent and tetravalent. This is regarding about the failure of valence bond theory, which is also called as need for the concept of hybridisation. And the next important topic in this chapter is the hybridisation, which is important for this chapter also for the whole chemistry. That topic will be discussed in the next lecture. That means remaining part of this unit will be discussed in the next lecture.